Okay, so everybody did their homework? We did a good job on it? Are you lying? Well, so I clearly see the homework dealt with fractions. So what were we supposed to do? We already had add fraction, right?
We're supposed to divide, multiply, subtract.
That's nice.
That's not it. Yeah. If that happens again, just touch the upper toolbar and it should go back to type.
We're good. All right. So we were supposed to subtract, multiply, divide, reduce. Or we already wrote reduce.
Yeah.
Was it? Was blah, blah, blah?
It was already.
Was this it?
Yeah.
Just these three? Okay. How do we subtract fractions?
Same thing as adding, but subtract instead.
Okay. Same as add, but subtract instead. All right. So let's go write subtract, because we already have add. Make sure I didn't write headers for the rest of them. All right. So we'll call this subtract. That. Let's put a minus sign in there to subtract the numerators. All right, so there's subtract fractions. How do we multiply fractions? Do who?
Multiply the top bucket by the top bucket and the bottom bucket by the bottom bucket.
Okay, do they need to be the same denominators?
Yeah, but we did that as well. That automatically happens because of the program. We wrote that down below, I believe.
All right, so we multiply the numerators by each other and the denominators by each other. Okay. Multiply there, but we don't have a new denominator, correct? We actually don't even do new numerator, new denominator. We're going to do this. So we don't need a common denominator. So the answer will be equal to cat at bucket 0 times dog at bucket 0, comma, cat at bucket 1, comma, times dog at bucket 1. Like that. So the two numerators multiplied by each other equals our new numerator. The two denominators multiplied by each other equals our new denominator. Return answer. All right, so that's multiply. Finally, what's divide? What does it mean to divide fractions?
Multiply by the
So same as multiply, but the second fraction we have to flip. Okay? So, well, let's steal most of multiply.
Could you just call multiply after you switch?
Oh, we actually can. We actually can. So we're going to say int array temp is equal to dog at bucket 1, dog at bucket 0. So don't actually change dog, but we'll give ourselves the reciprocal of dog inside of a variable called temp. and then we will return multiply of cat and temp. Like that. All right. So get our reciprocal of the second value, then call our multiply fractions, passing it our original first fraction and our new second fraction, which is the reciprocal of the original second. That work? All right, questions about that?
Can you write the call for him?
Yeah.
Okay. Because I know I didn't do it.
So let's do, well, we already saw add fractions, right? So let's do subtract fractions. So what should 1/2 minus 1/4 be? Oh, do I print out the...
Yeah,
You just have to bring it up.
hang off the original and then reduce one.
So 1/2 minus 1/4, this is...
4/8 minus 2.
Okay, so it's 2/8. We got the right answer, right? Okay. So that's subtract.
But how do you stack them on top of each other? Would you have to copy that whole thing?
You have to
and
make a
just
new answer.
keep them going?
Oh, you could just display it.
Okay.
So here we can do this. Well, yeah, you'd have to make a new answer since we're
And just is everything.
yeah, we'll just use it. We'll just use answer since we already wrote it up there. So this will be multiply. What should multiply be?
1/8.
Okay. Let's just see that real quick. 1/8, 1/8. And then what should divide be?
2.
2/1. Is that what you wanted to see? All of them printed out?
Yeah, I just wanted to see how you stacked them like that because I actually ended up doing different integers for each method. So I had like answer 1, answer 2, answer 3, and just ran them through like that.
I mean, you could also write your own method that just takes in your two fractions and then calls all four things on those two fractions.
All right.
All right. Other questions on this? All right. So everybody got the homework done? Got it working? So I don't need to give you an assignment over Thanksgiving?
No. That's why I brought you coffee.
Oh, that was...
It was a bribe.
So did you do your homework?
Yes.
Because you were asking me a question last night about the 325, not about...
325 I got that done. Just to warn you though, it is a weird solution.
I just assumed that with yours.
I started drinking Crown and Dr. Pepper.
While you're doing your homework?
I'm more creative.
All right, so now that we've looked at that, now let me just throw something out here real quick. Right now, our reduce fraction is not a very good reduced fraction. And let me kind of show you that real quick. That will be, I think, a benefit. Yeah, this will work. So what I'm going to do is I'm going to use our random class to be able to generate random numerators and denominators. Get some big values in there. So I'll import that. Just get rid of all this stuff here for a second. So I'll have our int array answer. And then we're going to have a for loop for int I is equal to 0, I is less than 1,000, I plus plus. Good enough for now. And then what we're going to do is we're going to generate fractions, and let's get our initial fractions going here. So we're going to say answer is equal to, we need to get a random numerator, random denominator. So r dot next int, let's say 100 plus 1. And we'll say this should be a comma. All right, so that's what answer is going to be. It's going to be a random numerator that's not 0 over a random denominator that's not 0. So it'll be a number between 1 and 100.
So is that what next int does? Is it moves it over?
Next int, we've used the random class before, right? In here. So if we call next int with no parameters here, it gives us a number in the range of all integers, negative 2 billion to positive 2 billion. There's a version of next int that takes a single integer. This will give us a value, so I'm passing it 100. This will give us a value between 0 and 99 inclusive. So by adding 1 to that, I'm guaranteeing it's a 1 to 100. So I'm adding 1 guarantees it's not a 0, is all I'm doing there. Same thing here. So this is going to be some number between 1 and 100 and some other number between 1 and 100. That'll be our initial answer. Okay, then our that should be okay, actually. We'll just need an initial answer.
We want the answer to be our.
I'm priming the pump, if you will, just before we get into this loop so I can use answer over and over again. So what I'm going to do in here is I'm going to say answer is equal to, and we'll just do add. That should be, actually let's do multiply. Multiply fractions, answer, and I'm going to need to give myself a temporary fraction here. So int array temp for the loop, and then I'll say temp is, oh, actually we can't do it that way. I have to define it in the loop in order to use our special syntax. So it's going to be the same thing as what I did for my answer up there. So I prime the pump by setting answer equal to some random fraction. Then I'm going to do something 1,000 times. Each time through, I'm going to generate a new fraction, temp, that's going to be some random fraction. And then I'm going to set answer equal to multiply fractions of answer and temp. And then I'm going to say answer is equal to, actually I don't need to say equal to because it's, we do it in line, right? Our reduce, or our reduce changes the fraction in itself. We don't have to return it. So I'll say HW dot reduce answer. Okay, so the hope is this shows what I'm about to tell you. So we're going to try to add, we're going to try to multiply 1,000 random fractions by each other. And we're going to keep accumulating the answer inside of answer. All right, but each time through, we're going to reduce our fraction. Now, currently, the way we're reducing our fraction is a brute force approach to reducing fractions. No big deal. In fact, if we look at reduced fraction, there's no heavy math here, right? This is all seemingly safe stuff. Reducing fractions is actually what's known as a time complexity problem. That is, using our current algorithm, reducing very, very large fractions will take a very, 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 very long time. Okay? Noticeably a long time. So we'll see if we can produce it with this. If not, we might have to force the issue a little bit. These still might be small enough fractions that our current code fakes it enough, that our computers are fast enough that it seems like it's happening instantaneously, but I think it might not. So at the very end, we're going to do a hw.display fraction answer. Okay, so after we multiply the fraction by a random fraction 1,000 times, we'll display it once. Okay, so I'm only outputting once. And remember, I think we've shown another time that when you display often, it slows things down, right? So in this case, I'm only displaying one time. So that's not going to be our slowdown. So let's run this and see how long it takes. Is it cooking?
So I think mine didn't go.
I think it might be cooking. Wish I can.
It's been taking a while.
Huh?
It's taking a while.
Okay, good.
Maths aren't
This
so,
is where your computer explodes.
No, it's not working.
You sure?
Yeah, because down there.
Here, let's just do this. Starting. Finished. Okay.
That's a way to do it.
Clearly running, right? My code does say finished at the very end, by the way.
So this is an example of memory inefficiency.
Not memory inefficiency, a time complexity problem. Yeah, this isn't memory inefficient. It's mathematically inefficient. And it's kind of a joke thing. And I stumbled upon this. I mean, this is a fact, but when I learned it was actually way, 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 way after you guys are learning it now. I was in a programming competition. I think I've introduced it to you guys in here. I've told you about Top Coder. Okay. So in my early days of Top Coder, my Top Coder handle was Playground. That's a thing from back when I was in Little League Baseball. I've been the big kid in the league for a while, but I actually wasn't always fat. I was a big athlete. I used to play close to professional tennis. I broke my back, and now I'm fat. But even before that, I was a big guy. Okay, so as like an 11-year-old, I was almost 6 feet tall. So I was like 5'11" or something like that as an 11-year-old.
So you were the tank.
Yeah, so the guy who used to announce our Little League games, I hit home runs all the time. I was this giant. And he, when I was coming up to bat, he's saying, next up, Mike, the playground, because I always hit the ball to the playground. Get it? Haha. So there's the backstory with that. But in any case, I was telling you. And somewhere out there, I should just actually look it up at some point, because you can go back with Top Coder and do old exercises. Okay, but it was one of the, I think it was the 500-point question in Top Coder. So every competition is an hour, and you have a 250, a 500, and a 1,000-point question, and they're supposed to get progressively more difficult. And the 500-point questions seem trivial. So you look at it, it's like, oh yeah, so you're going to take in, have two fractions, both represented as arrays. And you're going to add, no, actually, what is it? They're going to give you an array of fractions, where each fraction is a 2-digit array. Okay, do bucket array, so it'll be an array of arrays. Your goal is to add all those fractions together and produce the result in reduced form. Okay, so they gave you like 1,000 fractions or 10,000 fractions, something like that. Okay, some non-ridiculous number of fractions. And the numerator and denominator were going to be some number between 1 and like 9999999. A big number, but not a ridiculously big number. Okay? And you had to just sum it all up and show the answer in reduced form. Well, a couple of the rules, and this is when I learned about this rule in the competition, was your program had to run in less than 10 seconds. That was the rule. Before that, I never even considered that would be a problem, right? So I wrote the solution. Easy solution. Oh, I got like, I don't know, 491 of the 500 points for the time it took me to write it. So oh, easy. That's going to really help me in this. Then I was shocked when I failed the tests because I didn't finish in time. So I went back for like the next couple of days trying to figure out what the heck was going on. Like, why didn't this work? Everything I tested worked, blah, blah, blah. So that's when I kind of stumbled across this idea that reducing fractions is actually a time complexity issue. And my code was taking longer than 10 seconds to run. So cost me competition, but whatever. Good learning thing. And we see this thing's still cooking. Okay, this thing's still cooking. Okay, and we're only trying to add or multiply 1,000 fractions.
What does it take to do 100?
I'm sure about the same amount. You can't even stop it. Look, I am busy. We could probably do 10. 10's going to be too big too because we're multiplying. Just to make sure we didn't write any bugs in our. Really? Here, we'll do a 3. There we go. All right. So we're seeing this thing's getting out of hand pretty quick. Okay.
That's not reduced completely though.
Yeah, it's reduced.
It's got 6 numbers on the top and 5 on the bottom. You can take out a whole. So that's not technically
Yeah,
completely
but
reduced.
even
No, but this is it's reduced by the. This guy is not evenly divisible by. Oh, I get you.
Yeah.
I get you. So it's not the 2. Actually, this is reduced.
Yeah.
I think the notation you're talking about isn't necessarily considered reduced. What's that called?
1 and you're taking 1 1/2.
Yeah, that's got a name. What's that called? What's that format? What's that notation called?
oh,
We
come on.
studied this
Yeah,
10 years
this-
ago. Concussions ago, man.
Yeah, right.
Is it just complex numbers?
No.
That's
Mixed number.
mixed numbers.
Mixed numbers,
There
that's
you
it.
go. So I gave it that.
If it was only 10 years ago, I would have remembered it. It's a little more. When do you learn fractions?
Like
Mixed concussions.
Mixed fractions or mixed numbers.
Mixed numbers, yeah. What grade do you learn fractions? Third grade, fourth grade, somewhere in that ballpark? Yeah. How old are you when you are in 3rd or 4th grade?
Not old enough.
I don't remember.
Is that when I was 6 feet tall only? Like 10?
That wasn't
And
like 4th
maybe
grade.
we turn it 9 in 3rd grade.
My gosh. So I had this stuff almost 27 years ago.
Before any of us were.
Yeah, or any of you 27. We usually have 1 or 2 older students. Is anybody in here 27 or older? Are you the? You are? How old are you? Is that you're not telling? Are you? You're not over 30. No, you're like 28, 29. Yeah.
Yeah, not the oldest one. Yes.
Well, I think I told you when I first started teaching. I started teaching when I was 21 at college, and I got my degrees pretty young, and it was very common for me to have students that were older than me, like half the class or sometimes more. Especially when my grad classes, everybody was older than me, but that doesn't happen as as much anymore. I've caught up.
My 10 just finished.
Did it?
Yeah.
And just finished? Okay, so in any case, our problem here is with our reduce. So right now, first thing we do is we try to find the smaller of the numerator and denominator. No big deal, okay? That's not costing us any time. Right? This isn't the problem. This is what I'm getting at. Our while loop here, what does it do? It goes through every single number between smaller and 1. Subtracting 1 each time. Trying to find one that evenly divides both the numerator and the denominator. Do we have to go through every single number? Well, for starters, do we need to go through, do we need to start at smaller? Is it possible that smaller could evenly divide the larger and the smaller? Is that possible? It is. Is it if it doesn't, let's say smaller does not evenly divide numerator and denominator. Is it possible for smaller minus 1 to evenly divide numerator and denominator? It's not. Why? It might evenly divide the larger of the two. But if your smaller number is 5, okay, and let's say 5 does not evenly divide the other one, will 4 ever evenly divide 5? Will 3 ever evenly divide 5? And 5's kind of a bad example. Let's go 6. Will 5 ever evenly divide 6? Will 4 ever evenly divide 6? Not until we get to 3. Does that make sense? Okay. So, what can we do instead of subtracting 1 from it each time to make this a little more efficient? Go ahead.
I was one for that one, so I guess I can.
Let's give ourselves an example here so we can think through it a little bit better. So let's say we have the fraction 6 1/11. This guy already reduced? Okay, good. At least for this example. All right, so we're going to find out what the smaller number is first. So we determine 6 is the smaller number between those two. Now we're trying to reduce this. So we ask, is 6 evenly divisible by 6? Yes. Is 1/11 evenly divisible by 6? It's not. So right now what we're doing is we're going to try a 5. Now, regardless of whether 1/11 is evenly divisible by 5, 6 can never be. Make sense? Not until we get to a 3 is it even possible for 6 to be evenly divisible. Make sense?
So instead of minus 1, you would divide it by 2?
Well, tell me. Not always divide by 2.
That would be the only time that would be divisible.
Say this again.
Because if it's odd, you can't divide by 2.
What's the square root of 6?
Can we reduce the 1/11? Like, we reduce the...
Well, we're going with our current example where we're starting with our smaller. Actually, I'm interested. Square root 6. Ha! Look how smart that is. I like that. I don't think it used to do that. Anybody have an older, not running, anybody not running Yosemite? Still on Mavericks? None of you are still running? Okay, anybody older than Mavericks?
The lab across the hall.
Yeah, I'm proud of you. Everybody in here who has a Mac is running, do you guys seriously have matching HPs?
No.
Oh,
Different models.
Oh, they just look the same?
They're different things.
What's this?
NV Pavilion.
Which is the better machine?
They're both PCs.
This is newer.
This is newer. Crap.
PC.
Say
My 5K iMac should come tomorrow, I think.
I get to play with one of those soon.
Well, I'll have one in my possession.
What time?
Playing World of War, well, whatever time FedEx comes to campus.
I have one to play with every
What
night.
are you keeping it in your office?
Officially, yes. No, I do all my video game playing at home.
Can you have it here like Monday so we can doodle an owl over it?
But it's funny. Apple sends me an email the other day saying, we're sorry, but you're, because it's already been delayed several times. I mean, I think they're having issues making these 5K monitors because nobody's making 5K monitors. So they sent me and I also upgraded like the graphics card and stuff like that, for optimal programming.
No, those frames per second on Pro.
World of Warcraft is going to look sick is when it comes to. But for so I upgraded a couple other things on it. Hard drive I kept smaller. I don't put a lot of crap on the computer, but in any case, it kept getting delayed. So I get this. So originally it told me it was going to come like on the I don't know, like by the 10th. Then it kept delaying it. So I get this email the other day that says, it's delayed again. Expecting it to ship on or around December 2nd. Okay, well, whatever. It is what it is. 10 minutes later, I get an email with a tracking number. Your item has shipped, blah, blah, blah. So
Let's track it and see where it is.
last time I tracked it was somewhere in Japan. I left China, went to Japan, and
I'm more than likely maybe here today then.
its estimated delivery was,
I know, but sometimes it's ahead.
you think? Let's check.
How much was it?
A lot.
I don't know, school paid for it.
I'm just thinking about the.
Yeah, the school bought it for me.
Yeah, I'm just thinking how much a 4K monitor itself would cost.
4K monitor is $3,200. I think this machine was it's a 5K monitor plus the Core i7, better graphics card, 1 terabyte. I think it was not even 3,000 fully. With I think I only put 16 gigs of RAM in it.
Okay.
Here, I'll track it here real quick.
Black Friday, we have a 4K. Well, it's actually not true 4K. We only do like 2.5.
Nobody's using 4K anymore. Now you have 5K.
I know. I was just saying.
I actually have a 4K monitor put screen up that I use for the platform for my toaster.
Jeez.
What?
Why does your toaster need a platform?
Well, I don't know. What else am I going to do with that monitor?
Sell it to someone?
I wouldn't want to put that kind of antiquated technology in anybody's hands.
Oh, yeah, sorry. So 5K.
I'm having the reverse problem that you're having. I bought a 2 terabyte backup drive yesterday, canceled the order, and they shipped it anyways.
Did you get your refund?
I don't know. They said they would send it back in 3 to 5 business days. So I hope it doesn't get here. And then they're like, oh, well, you gotta keep it now.
Oh, so close.
Maybe like you have to pay to ship it back. For like
Yeah,
in Chicago or something.
I'll probably just keep
No,
it.
the search, the email search, it keeps updating live. And I saw the email and I went to tap it, but it updated. Your order is on its way. Got it. All right. Tracking. If it's here now, the class is over.
No, go get it and let's go play.
Oh, actually, you're right.
Yeah, we'll be here today. Won't we?
Downstairs.
No, I mean, you're rarely right.
We'll be
It's
here
just like it's still hold on, it still says estimated delivery is Wednesday 11/26.
But it's not for transit.
Yeah, it's in Milwaukee on vehicle for delivery.
Yeah, because when I ordered my iPad, I ordered it on Wednesday and I had it like Monday.
What time does FedEx usually get to campus?
Anywhere between now and 2.
It's normally
No, I mean for faculty. Like really, like this morning?
11.
Like if you're tracking it, it says in Oak Creek or doesn't matter.
Is anybody going by the mailroom?
I'll go after it.
Right now.
If it says in Oak Creek or Alfred.
They probably like want to get somebody delivered to my office, but
Yeah.
if you let me know, I can.
Email you probably.
I
They have a
don't.
large package here.
I don't think so. I think for faculty, they just deliver it to your office. We don't.
Quick run.
We don't have to do anything ourselves.
Quick run and check your office.
No, he would have gotten it saying delivery.
No, because they take a couple hours.
I'll get a thing from FedEx letting me know it was delivered.
Yeah, that's what I'm saying.
Yeah. Okay, well, now I'm excited. I can play World of Warcraft tonight on a 5K. So I'll be updating. It'll be in my office today, updating and downloading from Battle.net.
Do you need to mount it above your hot tub?
We could make that happen. Oh, when do you want to do that plexiglass shield on the TV?
I don't know. We'll talk about it. All right, so in any case, back to work now that we're all excited about a 5K monitor. So, square root of 6 is 2.444, blah, 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 right? So, if we took 6 and we subtracted from it its square root, what do we get? 3 point something, right? Okay, and that's truncated, okay, because it can't hold those values. Well, actually, let's keep playing this out. So let's say this is 7. Okay, well, here, we'll do the 6 first. So we tried to divide it by 6. 6 evenly divided this guy, but didn't evenly divide this guy. So now what we're going to do is we're going to take 6 and we're going to subtract from it its square root. Okay? Now we can do this 2 different ways. We can either truncate the square root and then subtract, or we can subtract and then truncate the result. So even if we truncate the square root, we're still gaining a benefit here. So we're going to say 6 minus 2, square root truncated, gets us to a 4. So we already are moving down more quickly. Does 4 evenly divide 6? No. Does 4 evenly divide 111? No. What's the square root of 4? It's 2. Does 2 evenly divide 6? Yes. But was it the right evenly divide? 3 evenly divided 6, didn't it? So did we skip the right answer?
Yeah, it is.
Square root's got to play into here. You got to play into this at some point,
Yeah.
right?
But 3.
It is.
Yeah, it's
3 is divisible.
Say this again.
both of them. Yeah, both of them.
What?
3 would have been your answer that you would want to.
Yeah, correct. We skipped it.
Yeah.
And we skipped it. And we don't want that. So we could have gone the other route. We could have said 6. 6 minus,
Square root.
well, 6 minus the square root is 3 point something. Truncate that, we have a 3. That becomes our answer.
What's the difference between that and dividing by 2?
In this particular case, there isn't. But we're looking for a
Yeah,
generic
something.
solution.
Okay.
Looking for a generic solution. Square root's got to be involved. What is the square root of a number? It's a number when multiplied by itself gives you another number, right? Okay. So isn't the square root of 6 the next number down that when multiplied gives you a 6? So we're not halving it. We're dividing it by its square root over and over and over again. But these have whole numbers, or these have decimal points rather. Where can the square root come into play here for at least reducing the number of things that we need to?
111. Right?
The square root of 111?
Yeah.
Okay, why?
Doesn't that come out to be, oh no, it doesn't.
Let's take it step by step. The very first thing we're going to try, whenever we're reducing fractions, is we're trying to look for the trivial reduction. That is, the smaller the two values evenly divides the larger the two values. Then we know we're done. Right? Okay, so let's do this as a human would do this. So we tried to divide those, didn't get there. Now, we glance at this. We know the next number that evenly divides 6 is a 3. We don't have to worry about how we got to that number. We just know, as a human being, we know that's the number, right? Okay, so 6 divided by whatever gives us a 3. So we say, does 3 evenly divide 6? Yes, it does. We already knew that. But does 3 evenly divide 111? Does it? Okay, so we get our answer. That's the largest, the greatest common divisor. Let's switch this to a 7. Does 7 evenly divide itself? Does 7 evenly divide 111? Nope. 15.8, blah, blah, blah. So nothing there. What's the next number that evenly divides 7? A 1. Okay, we knew that was the case. Look at an 8. 8 evenly divide itself? Does 8 evenly divide 111? Nope. What's the next number that evenly divides 8? 4. Does 4 evenly divide 8? Yes. Does 4 evenly divide 111? Nope. What's the next number that evenly divides 8?
2.
2. Does 2 evenly divide 111?
No.
Nope. Then we got 1, so it's already reduced. You mentioned that maybe we operate the square root off of the second guy. Well, how do you envision that working? Maybe the better question is why would it be the square root of the second guy?
To reduce it to a number that would be more evenly divisible. Is that?
Well, at the very least, it'd be a smaller number.
Yeah.
Okay, so if this guy does not evenly divide this guy, if these two are not evenly divisible by each other, will there be any number in here that evenly divides this guy? Before we get to this, I want to figure out the right way to ask the question. Well, here, let's do this one. Square root 111 is 10.5. Let's just say that. Just throw that number out over here. So this is the square root of that number. Okay? So 8 does not evenly divide 111. So what are we going to do? We're going to possibly take the square root of 111 to give us a 10.5. What does that do for us?
Is this a smaller number?
Okay, smaller number here, so we don't have to test all those numbers.
Right?
Is that good enough?
No.
Depends how big the numerator or the denominator was in this case, the larger of the two numbers. Okay? Probably not the way we're gonna do this. What if we start with 8 and saying 8 is not evenly divisible by 111, or other way around, so we're not already reduced in the trivial, well, we're not going to be trivially reduced. So square root of 8 is 2.83. Now we have 2.83 here. We'll take the square root of both of them. Remember what we're trying to accomplish. We're trying to find the greatest common divisor of both the numerator and the denominator. Largest number that evenly divides both of them. If 8 does not divide both of these, We're trying to figure out what is the most efficient next number to try.
In this case, it would be 2 if it's off the square root.
Check 4, then 2. So that's dividing it by 2 each time. Dividing it by 2 each time.
So where's the square root coming in?
That's what I'm trying to get out of you. It does. Testing our math skills. I promise you the square root's involved here. Actually, the square root is not involved in the most efficient way of doing this. We'll look at that here in a few minutes. That's the Euclidean algorithm. But if we're going brute force, let's do it more better. Have I used that term in here?
Yeah.
Yeah.
Or most bestest.
Most bestest, that's right. Okay, most bestest is Euclidean. But if we're trying to do it more better, we look at something involving the square root. So I'll start us off. We look at this guy. This is similar to our merge sort. This guy is not trivially reducible, right? That is, the smaller does not evenly divide the larger. So it's not trivially reducible. So now I might ask a follow-up question. What is the next largest value that might evenly divide both the numerator and the denominator? Right now we're going through all the numbers between smaller and 1. Correct? All the numbers between smaller and 1. We know for a fact, that 1 will evenly divide smaller. It's a math rule, right? Okay. What about the numbers between 1 and smaller? .83 is the square root of 8. Will any number smaller than this besides 1 evenly divide 8?
Yeah.
Will it?
Yeah.
Okay. Which number?
2.
Oh.
But if it gets truncated, that's what it would be, right?
Hey, if it's truncated. You want to truncate it?
Oh, I was just going to ask about that.
No, we're down a good path now. So the truncated square root is a 2. Will any number smaller than this besides a 1? 1's our math rule. 1's our math rule, right? What if you want to make this look a little bit let's say that's our numerator denominator. We already decided the square root of this guy was a 10.5-ish. So really it's a 10. Will any number besides 1 smaller than 10 evenly divide this guy? What number?
But I think 3 will go into that next number too.
Well, and 10 doesn't even go into there evenly.
No, we're not. I'm pushing us towards the boundaries
Yeah.
of all the numbers we need to test. Square root's going to deal with the boundaries.
So is it the square root? So like if
it gets truncated plus 1 and then the square root.
Right now we're testing all the numbers, in this case, between 1 and 111. Every single one of these numbers we are trying to divide by this guy.
So instead you're saying test between 1 and the square root?
Possibly. Might be possibly saying something along those lines. Would you agree that one of the reasons we're being slow right now is because we're testing every single one of these numbers?
Yeah.
Okay. So if we can figure out a way to reduce the number of numbers we're testing, we're at least improving things. Fair enough, right? So that's our goal right now, is to improve things. I promise you, whatever solution we come up with here, we're going to throw out the window when I show you Euclidean algorithm, okay? And I promise you that I tried this solution in that test case, the programming competition thing, and it got me farther down the solution, but I still timed out eventually, okay? So it's not the fix, but it's a fix, okay? Because we're dealing with time complexity right now. So our goal here is to reduce the number of values we're checking. See if we can cut out swaths of values. Make sense? Okay. So that's what we're trying to go for. Hey, old man. See, as you get older, it's a reduced bladder. If it hasn't happened yet, it's totally true. Just prepare yourself. Minimum of 3 times per night. And it's both sexes. My wife and I, we alternate. Except the difference is she scoops the litter box in between. My wife's kind of a neat freak. So yesterday the house did not get taken care of that well.
Surprised it's still standing.
It's true. In fact, actually, this morning my wife came in and wanted to know why there was a flower petal in the cat's food bowl.
I don't know.
Didn't you see this?
Nope.
It looked all right to me. I thought it was decorative. Cats like flowers, right? I thought it was part of the bowl. It had to be. I mean, the cats drag crap all over the place.
Yeah.
I mean, like each cat has their favorite toy.
Oh, jeez.
And you could hide that toy. They will find that toy.
Hide it in your car, they'll never find it.
Well, that might be true, but they'll just go into a sense of, like, Gracie has her favorite toy, and like when it's just covered in slobber after she's playing with it.
Next to the hot tub, so if they go for it, they'll jump into the hot tub.
Yeah. All right, so we're trying to reduce. We're trying to reduce this range, and I'm telling you, reducing that range involves the square root.
Okay.
That's what I'm telling you. Reducing it involves the square root. So, any other theories? Well, let's go a little bit different route. Here's this number. .33, good enough. So there's the square root of both of our numbers. Square root of both of our numbers. Right now, I'm testing every single number between 1 and 111 to see if it's evenly divisible by this guy and evenly divisible by this guy. If 1 is not evenly divisible, well, if 111 is not evenly divisible by this, well, the other way around. If this guy is not evenly divisible by 111, does 333.33 come into play? Is there any number in there between 333.33 that would evenly divide? 333.33 and whatever that other giant number is.
Oh, 2.
Well, I'm saying a number between these two.
Oh,
For instance, is 335. Could 335 evenly divide this guy? Oh man, maybe this is going to be our homework assignment.
no, it can't.
Can't be the homework assignment, or
No, it can't. It can't
or
divide.
yes.
Just leave it up to the teacher.
Is there a way we can find out which numbers do go into all of the numbers that do go into our denominator by using the square root?
Okay,
I don't know how.
you're having some theories. Okay, what I want to do here. Oh, what happened? We finally. Oh, we got to divide by 0 because it finally ran out of the size of int. That's what happened. It ran out of size of int.
Finally. How long did that take?
Well, actually, we just must have really bad luck for our multiplications.
How long did that take? Almost an hour.
No, because actually, it was one of our original ones we weren't able to kill. Yeah, we had multiple things going.
All of a sudden, you're gonna start getting fail codes.
So I'm just going to comment out this stuff here real quick. Now, what I'm going to do, let's just start with. Go ahead. Theory.
Can we use modulus and then use the remainder? And then
Okay.
figure it out from there.
Possibly. Use the remainder off of what?
Just doesn't modulus give you the remainder?
Well, it does. I mean, that's how we're testing our reduction already.
Oh,
Yeah, that's how we determine if they're evenly divisible. What I want to do is let's just pick our 111 as our example. Okay, so I'm going to say for int I is equal to 1, I is less than or equal to 111, I plus plus. Actually, let's go. I want to walk backwards just so our numbers kind of match up for us. If I mod, actually if 111 mod I is equal to 0, system.out.println I. So it's going to start at 111. It's going to print out every single value between 1 and 111 that evenly divide 111. Okay? That's what this code right here does. So we can see it as a list. Right? So we have 111. We have 37. We have 3. We have 1. Right off the bat, we see that a very small number of values between 1 and 111 evenly divided 111. Right? Right off the bat. Let's throw a couple other ones on there. Relatively speaking, a very small number of numbers. So if we could somehow only test those numbers, that would be beneficial. Right? Let's go back here. Let's bring it back to, doesn't matter.
Can we create a variable that stores all those numbers?
We can, but we're really looking for visuals right now. Yeah, we're trying to get ourselves to stumble upon how square root can play in here. Okay, and I believe this was 10.5, right? Okay, so I'm promising you square root is involved. That's given information. Okay, so I've already given you your hint. I have also told you that we're trying to reduce the number of values we're testing against. Make sense? Trying to reduce the number of values we're testing against. We know that the biggest value that the greatest common divisor can possibly be is the smaller of our two. We already figured that out last time. Okay? So if this is our numerator and this is our denominator, we know that the greatest common divisor must be less than or equal to the smaller of those two. We can't have a greater common divisor bigger than the smaller guy. 200 cannot be the greatest common divisor because one of our values is already smaller than that. Okay? So, we know the smaller of the two is our top number it could possibly be. Okay? We know that the size of our current range is our current problem. That's why it's slow. And we also know that the square root can possibly help, well, not possibly. The square root can definitely help reduce that range. Definitely help reduce that range. Those are all facts. We know the square root of 111 is 10.5. Okay, square root of 111 is 10.5. So let's print these out again. We'll start off at 111. Print out all the values that are evenly divisible. 111, 37, 3, 1. So just looking at these top two, if 111 does not evenly divide the first guy, well, we know it'll evenly divide itself, but let's say it doesn't evenly divide the larger of the two values. The next value that can possibly evenly divide both is a 37. That is the next value associated with 111. That make sense? Even if there's other values in the middle that evenly divide the larger of the two values, the next value that will evenly divide 111 is a 37. That make sense? Okay. So, how do we go from checking 111 and that failing to now knowing that the next value we need to check is something substantially smaller without going through all the numbers? So we start with 111, and now we know we don't have to check 110. We don't have to check 109, so on and so forth. Okay? Now, having said that, we might have to check a value in the middle. Might. Ideally, we'd only check these values. Go ahead.
Why can't we, instead of outputting it, why can't we check it like from the smaller the loop? Why can't we, like, you know how you did the modulus I and it displayed them? Can't we just check if those individually are divisible by the denominator is divisible by that? Whatever.
Denominator is divisible by what?
The ones, we figured out 111 for the,
It's
in the
still
if.
going through the for loop all those times to find those four numbers.
Yeah, I'm trying to focus us in on just the 111 part of this. Forget about what the denominator is, or what the larger of our two values are. So in our current example, we have 111 over whatever this number is, 111,112. So those are our two numbers. We know the largest greatest common divisor is going to be 111.
Kind of, but still going.
So our possibilities here, the only possibilities we have are numbers that evenly divide 111. Correct? There might be numbers in there that evenly divide this guy. But greatest common divisor will evenly divide both of them. Both the numerator and the denominator. We're going to start with the smaller number because that's at the very least going to make us look through less stuff. Okay? But now we definitely need to find a value that at least evenly divides the smaller number before we even try it on the larger number. Why try it if it won't evenly divide one of them? It's got to divide both in order for it to even be, well, it's got to divide both for it to be the answer. Okay? And we're looking for the greatest common divisor. That's why we start at the top. and work down towards 1, knowing that 1 will work. Okay? 1 means we just wasted our time. Because 1 divided by, it'll be the same numbers. Okay? And we look at our output here. We see that 111 is the first number we'll try. That's the first number that even divides 111. The next one is 37. The next one is 3. The next one is 1. Now, even if we can't get down to those exact increments, is there a way we can reduce? We've gone from 111 possible values down to 4 in this case. 4 values to try, which would be ideal, correct? But we want to reduce that range in the middle. 2 minutes to avoid a homework assignment.
Coffee?
Yeah, look at the code.
I'm really banking on that coffee.
The code in this case, I don't want to stray you. The code doesn't matter. The only reason I created this code real quick is just to visually show us the numbers that evenly divide 111. These are the only ones to try.
So is the square root always going to be in between?
Well, you want to look at square roots?
I mean, yeah.
So let's start I off at 111. Here, let's just do a second. Let's do a second loop, just so we have both of our numbers there. We'll do a little system.out.println. And appropriate Java conventions is this is the exact number of asterisks to use for dividing up printouts. I do it based on timing. I've been doing it so long, so it's. But this is the exact number, just so you know. So we'll start at 111. We'll keep going as long as they're greater than 0. But each time through, we're going to say I minus. Well, do we want to say that? Yeah, let's just do this. I is equal to math dot square root of I. I'm just going to complain. We actually need to cast this into an int. Because math, the square root of a number very possibly will be a double. Well, we'll very, very likely have decimal points, right? Unless it's evenly divisible. So this will print out all of our square roots. And just so we see the full values, I won't do the mod thing. I'm just going to print out all those square roots. Okay? So it's going to start at 111, and we're just going to keep taking the square root of that guy. Oh my gosh, stop.
Hey, this time at least stopped.
Just go greater than 1. That'll stop it. So keep taking the square roots. You got 111, 10, 3.
What are we looking for?
I'm looking for how square root plays into this solution. Okay. Something to think about over break. We will likely have a quiz when we come back. And I'll even tell you what to search for. Okay? Determining the greatest common divisor, GCD, without using the Euclidean algorithm. I don't want you to see the Euclidean algorithm yet. We're going to talk about that next class. So anything that comes up that says Euclidean algorithm, ignore. All right? How can we use square root to reduce the number of comparisons? We might have a quiz. We might have more discussion. Depends on the mood I'm in. And how quickly today I get my iMac. All right, make sense? You don't have to write anything. I just want you to consider it. Next time you're in the bathroom, pull out your smartphone and do a search. Okay? Have a good Thanksgiving. If you're traveling, travel safe. I will see everybody next Tuesday.